What is the resolution? Resolution is defined as the smallest incremental of the input quantity to which the measuring system responds. Okay, so it is the magnitude of the input change which results in the smallest observable output. Okay. Example, if we are considering the digital voltmeter with a resolution of 0.1 volt, is used to measure the output of a sensor. Okay. The change in input, for example, temperature, pressure, etc., that will provide a change of 0.1 volt on the voltmeter in the resolution of the sensor or voltmeter system. So in digital systems, generally, resolution may be specified as 1 by 2 to the power of n, where n is the number of bits over on it. Okay. The next one to be the threshold. So, if the input to one instrument is increased very gradually from zero value, there will be some minimum value of input below which no output change can be observed or detected. This minimum value of input defines the threshold of the instrument. Okay? So, the minimum value of input defines the threshold of the instrument. Okay? What about drift? So, drift is a slow variation in the output signal of a transducer or measuring system which is not due to any change in the input quantity. Just it is a slow variation in the output signal of a measuring system. At the same time, it is primarily due to changes in operating conditions of the components inside the measuring system. Okay. The drift is noticeable as a zero drift and it is to be a sensitivity drift. So what about zero drift? Zero drift is the deviation observed in the instrument output with time from the initial value. All the other measurement conditions are to be a constant. This may be caused by a change in component values due to variation in ambient conditions or due to aging overall. Okay. The next one to be the repeatability. So it is also called as reproducibility. That is, the failure of the sensor to represent the same value under identical conditions when measured at different times. So actually, it is usually associated with calibration. Okay, and it is given as percentage of input to scale of the maximum difference between two readings taken at different times under identical input conditions. Okay. So whereas the repeatability is equivalent to maximum minus minimum value divided by full range, and we'll be calculating in terms of percentage value. Okay. The next one to be the dead zone. What is dead zone? It is the lack of response or insensitivity of a device over a specific range of the input. Okay. So in this range, which may be small, the output remains constant. A device should not operate in this range unless this insensitivity is acceptable. So a dead zone is also known as an dead band or dead space. Actually, it is due to static friction, backlash, or hysteresis. Okay. So dead zone is the lack of response or insensitivity of a device. Next one to be the hysteresis. So what about hysteresis? Actually, it is the maximum difference in output for a given input under loading and unloading conditions. It is caused by electrical or mechanical system. So actually, we'll be having often it is due to magnetization, thermal properties, and loose linkages. So if the temperature is measured at a rated temperature of 50 degrees Celsius, so the output might be 4.95 volts when temperature increases, but 5.05 volts when temperature decreases. So what happened? So this is an error of plus or minus 0.5% for an output full scale of 10 volts. So this is an ideal example for hysteresis. And the next one to be the linearity. What about linearity? The linearity of a sensor is referred to the output that is directly proportional to the input over its entire range. Okay. So the linearity, that is, it should be the if there is a gradual increase in the input, then we should have a gradual increase in the output. Okay. Suppose if if an error occurs, so what will happen? So we'll be having often, so we doesn't have any direct proportion over on it. Okay, so see over that the slope of a graph for the output versus input for the linearity case will have a straight line. So if an error occurs over on it, so we'll have a curved shape for non-linearity. Okay, so the linearity is referred to the output which is directly proportional to the input over its entire range. So the next thing we are in need to know, what about the range and span? What about the range? It is the lowest and highest value of the sensor. Okay. Span is nothing but the arithmetic difference between the highest and lowest values of the input that being sent over on it. Okay. The next one to be the input full scale. That is the IFS span. Okay, so the input full scale is nothing but the span value. That is the difference between the highest and lowest value of the input. What about output full scale? So it is the difference between the upper and lower ranges of the output of the sensor overall. Okay, and the last one to be the dynamic range. So which is nothing but the ratio between the upper and lower limits, and it is usually expressed in decibels. So this is the which helps to do the problems over here. So see over here, a sensor is designed for minus 30 degrees Celsius to plus 80 degrees Celsius to output 2.5 volt to 1.2 volt. What about the range? So range is the which is given over the upper limit and the lower limit of the sensors over here. So which is to be the minus 30 degrees Celsius and plus 80 degrees Celsius. Whereas in the case of span, so the difference between the arithmetic value of an 80 to 30 over here. Okay. So 80, the difference between the value to be 80 of to be the minus of minus 30. So we'll be getting the span range is around to be the 110 degrees Celsius. So we know that what is input full scale. The input full scale is nothing but the span value what we have obtained over on. So it is equivalent to 110 degrees Celsius. The next one to be the output full scale. The output full scale is nothing but the we have to calculate the difference between the voltage over here. 2.5 volts minus 1.2 volts. So we'll be getting off at 1.3 volts. So whereas in the case of a dynamic range, we have to take the logarithmic of the voltage value. So we'll be getting the value in terms of an decibel, 13.38 decibel. So the next thing we have to define what is bias and tolerance. What is bias? Bias describes the constant error which exceeds over the full range of measurement of an instrument. Okay. The error is normally removable by calibration. So whereas in the case of tolerance is defined as the maximum error which is to be expected in some value. That is, the tolerance describes the maximum deviation of a manufactured component from some specific value. Electric current component, which is resistors, have tolerance of perhaps 5%. So far what we have seen over and term, we have seen about the what are all the static characteristics of a sensor element. Okay. So we'll see about the dynamic characteristics